Welcome to the part 2 of the episode Testing How. Did you enjoy your coffee? Me too. Let's start. In order to write our first test, we need some code. For this purpose, we can use the class diagram shown in the slide. It consists of 4 classes: Invoice, Position, Product, and Product Manager. I would like to start with the class Product. This class represents a product which can be sold in a shop, for example. The product has following fields: ID, name, and price. The next class is Position. This class represents one position in an invoice. Any position has information about a sold product and its count. The next one is the class Invoice. It represents a simplified invoice, and it has the following fields: ID, date, and the array positions, consisting of instances of the class position. The class Product Manager represents a product factory and delivers products from the database. As you see, the classes Product and Position are very simple. And I would like to take a closer look at the class Invoice. Let's walk through a code. In the method init, each instance of this class is initialized with an empty array of positions. The method addPosition adds a new non-empty position to the array. The method removePosition removes a position given as the input parameter from the array positions. And the next method is getNumber of positions. As the name says, it gets the number of items in the positions array. And the method getTotal, it calculates the total sum of the invoice. If the total sum is greater than 50, the customer gets the discount 10%. And the most interesting method to test here is, of course, getTotal. And there are some testing paths or scenarios in this method. Let's look at them. On the right side, we have our method under test, and on the left side, I will list possible testing paths. And I will start with the happy path. So the first one is the array position has some item, but the sum 50 is not achieved. Here we expect that the total sum is without discount. The next happy path is the array position has some items and the sum 50 is achieved. Here we expect that the total sum is with a discount. And the last happy path is the array positions has no items. Here we expect 0 as total sum, of course. And then we have our dirty path. The first one is the instance variable, our array positions is nil. Of course, a runtime error occurs here. The next dirty paths are getProduct returns nil, getPrice returns nil, and getCount returns nil. They are dirty paths because we don't expect this situation in this method. Also, in the method, we can test boundary conditions. They refer to the methods getPrice and getCount that should return values greater than 0. As you already know, we have 3 possible conditions: the value less than the boundary, and the value equal to the boundary, and the value greater than the boundary. So, the first one is the method getPrice returns a negative number, or the method getCount returns a negative number. And we have more. The method getPrice returns 0, and the method getCount returns 0. And the last boundary testing paths are when the method getPrice and getCount return a positive number. But we have covered these paths with the first two happy paths. So here we have listed so many testing paths for the method getTotal. And you can see how many gaps or missing requirements in the method implementation we have. It was not taken into account what happens when the method getCount or getPrice return 0 or a negative number. For this reason, thinking about tests is a helpful tool to discover gaps in any code at the earliest possible moment. And now let's look at the unit test for this method. Here we can see a unit test for the method getTotal. I would like to test here the situation that the discount exists. It means the sum 50 is achieved. So, in the first phase setup, I create an instance of the class Invoice. Then I create an instance of the class Product with the name Cheer and the price 30. Then I create a new position with the created product and with the count 2. And then I add the new position to the invoice. In the phase exercise, I call the method getTotal. And in the last phase, verify, I check with the verification column checked integer equal that the expected result, 54 here, is equal to the returned result from the method getTotal. If they are equal, the test passes. If not, the test fails. And now the next interesting class for testing is Product Manager. Let's have a look at this code. I remember you, the class Product Manager represents a product factory and delivers products from the database. So this class has the class variable product factory that is initialized in the class constructor init class. This class constructor will be called automatically when the class is loaded for the first time. Also in the class, there is the class method createTable that creates a table with products and fills it. The next method is init. This is a constructor that initializes a new instance of the class Product Manager. Also, it opens the table products. And the last method is getById. It searches a product with a specified ID in the table products and returns it. So, since the class Product Manager needs to communicate with the database, we can write some integration tests here. So, and I would like to test the method getTotal here. And now the question is, which testing paths we can go through this method? Let's look at them. On the right side, we have our method under test, it's getById. And on the left side, I will list possible testing paths. So, happy path. The first one is when the input parameter in ID is an ID of existing product. The next happy path is when the input parameter and ID is an ID of non-existing product. It's a normal situation. Here we can search different products and sometimes they don't exist in the table. And I can start with the dirty paths. So the first one is the input parameter and ID is nil. And the next one, the table products does not exist. Ooh. This is a runtime error here. Here we have listed some testing paths again. But the scenario when the input parameter is nil was not taken into account. One gap more in my code I have to take care of. So let's look at the integration test. This is my integration test for the method getById. And here I would like to test the situation or scenario when the input parameter is an ID of existing product. So in the phase setup, this is our first phase in test, and I create our test environment for the test, for this test. First, I create the table products and fill it, and then I create a new instance of the class product manager. In the phase exercise, I call the method getById with the parameter 10. In the previous phase, I create and filled the table, and I know there is a record with the ID 10. So, and I would like to get it. And in the verify phase, I check it. So, in the first line, this is the verification command check object type. It checks that the returned value is of object type. And then in the line 2, I compare two numbers, check numeric equal. I compare that the expected product price is equal to the return product price. And in the next line, I use the verification command check string equal, and I check that the expected product name is equal to the return product name. And here we have the phase tear down, and in this phase I clean up all allocated resources. So I delete the table products and its indexes. And I think it's a good time to start with the Xbase++ workbench, and we can write our first tests. I go to my workbench. It's here. Now you can see it better. Here you can see the class product. It's very simple, and then the class position. It's very simple too. And now the class invoice, it's more complex. Here we have seen already. And my task is to add a new method, getPositionByIndex, to the class invoice and write a test for it. The requirement is when the input parameter is equal to nil, the method should return nil too. And as you see, the new method has at least two testing scenarios, when the input parameter is not nil and when the input parameter is nil. So let's start with the testing. Since I follow the principles of test-driven development and write tests before production code, I will start here with writing an empty implementation of the new method and then create tests for it. Let's start. I can declare the new method getPositionByIndex. So now I can write an empty implementation. We have input parameter and index, and empty implementation, the method returns nil. This is our empty implementation. Then I can build my project. Perfect. And then I can create first test. So I click on the root node in the product manager tree, and I open the context menu. Here I choose add new target, and in this window we can see unit test. This is what we need, and I say call. And now you can see we have the new target runner here, and in this target we have the new test file or test group. This is a template here, and now I can create our first test. Method test getPositionByIndex, and I would like to test the situation when the index is not nil. When an index is not nil. and I can implement it here. I prepared some code for the test and I will try to paste it. Now we have our first test here, and in the phase setup I prepare our test environment for this test. So I create a new instance of the class Invoice, then I create a new product with the name Cheer and the price too, and then a new position. Here I add the new position to the invoice. In the phase exercise, I call the method getPositionByIndex. And in the previous phase, we create an invoice that has one position. And I would like to get this position in this phase. And in the phase verify, I check that the expected position or position is equal to the returned position, returned object. And here I use the verification command checkEqual that checks that two objects are equal. And here the content of the objects is compared. I can build my tests. Oops. Oh. It doesn't know my library. I have to include my library. Pragma. Library. Invoice management lib. Okay, I try it again. Super. And I can run my test. Run. And here we can see the test failed. And it's normal here. You see the error message is expected O, it means object, but was undefined, it means nil. And as you know, our method implementation returns nil, and it's okay here. And according to the test-driven development principles, when we run the test for the first time, it should fail. So it's normal here. And now we have to implement our method. So I go back, and now I can implement my method. If an index is not nil, I can return positions by an index. If not, I return nil. So now I built my project, my method, and then I built my tests again, and I can run my tests. You see, here it's okay. The test, our test get position by index when an index is not nil, passed here. Here we can see this is the timestamp when the test was executed. Then we can see test state, it's passed here, not failed. Then we can see the test name and the duration time. And in the last line, we can see how many tests there are in the test group, how many tests were run, and how many checks our verification commands were executed, and at the end, the total duration. Also, you can run your tests if you when you click on the target runner and you open the context menu. Here you can see run all tests. So, and we have the same result. The difference between runner and my group, if I call run all tests, On the runner target, all tests that there are in this project will be run. If I call the same command on my test group, only tests that there are in this group will be run. So now we can back to my presentation. Yes. And we go through. So on this slide, we can see verification commands of the XPP unit framework, which we can use in our tests. And the first group is logical result. And the first command is check true. It checks that a given expression is true. If not, the test fails. And the next one is check false. It checks that expression is false. If not, the test fails. So the next is value comparison and check equal. It checks that two objects or arrays are equal. Here the content of the objects or arrays is compared. The next one is reference comparison. And the verification command is check same. It checks that the two objects are equal, and here the reference of the past objects are compared. And the last group of in this slide is number comparison. And the first command is checked integer equal. It checks that two integer values are equal. And the last one is check numeric equal. It's the same, but two numeric values are equal or not. The next slide here. The next group is string comparison. And the first command is check string equal. It checks whether two strings are equal, and here happens case-sensitive string comparison. And the next one is check string no case equal. It's the same, but here happens case-insensitive string comparison. And the last one, it checks that whether the first n characters of two strings are equal. And the last group in the slide is type checks. They check whether the given object is an instance of specific type. For example, logical, character, number, numeric, and array, and so on. And summary. I listed some benefits of testing in this slide for you. And the first one is early defect notification. Tests improve your chance of detecting any given defects at the earliest possible moment, which tends to minimize the work needed to diagnose and correct a defect. And safety net. Tests provide a safety net for code changes because they increases your chance of quickly detecting defects inserted during their modifications. The effectiveness of the safety net is determined by how completely your tests verify the behavior of the application. Missing tests like a big holes in the safety net. Each gap in the safety net can let defects through. And the next benefit is software quality. The very fact of thinking through various scenarios in enough detail to turn them into tests help us identify those areas where the requirements are ambiguous or self-contradictory. Such analysis improves the quality of the specification, which improves the quality of software. And the last one, time money gain. Putting testing into your development process, like test-driven development, makes each development process faster. Thanks, test-driven development defects are discovered earlier, and it makes you, developer, more cost-efficient for your company. I love tests. And you? So, I hope you enjoyed the episode and found something useful for you. My goal today was to tell you what kind of software testing and testing concepts there are. Also, we have learned how you can write and run tests with the Xbase++ workbench. Have a nice day. See you next time. Bye.